This is for Year 11 Specialist. We're going to look at vector proofs in exercise 20E. In particular, we're going to look at question 7 and question 8. So we'll do question 7 first. In question 7, we're trying to prove that the midpoints of any quadrilateral are the vertices of a parallelogram. So essentially, to prove that, we just need to prove that EF and HG are parallel to each other, to prove that it's a parallelogram. Now, I first need to represent EF as a vector. So EF, we can say, is given by a half of AB plus a half of BF. And that's what my EF is. Now, what you'll notice is that EF is actually half of AC. It is half of AC because if we look at this closely, this triangle and the triangle that includes the diagonal in the middle are actually similar triangles. We can see that since this is a midpoint, if this is 1, this is also 1. So whatever that length is double. So it means that EF is actually half of AC, because it's, since this is double of that, then one length of that would be just half of that. So I can similarly prove that for HG, because HG is given by half of AD plus half of DC. And again, since these two triangles are similar, this triangle and that triangle, and the relationship between the sides is, if that's 1 then that's 2, so it's double. Again, it is half of AC. So simply stated, these two vectors must be parallel. So therefore vector EF is parallel to vector HG. Now, since these two are parallel and of the same length, must mean FG and EH is also parallel. So we don't need to actually prove that. So therefore, we've answered the question that for any quadrilateral, the midpoints, when joined together, form a parallelogram.